Hey guys, we're going to do a 3.2 video today, and the essential question that we're working on is what is distributive property? So take a moment right now to grab your notebook and set up your notes and get that Cornell note-taking strategy kind of all put together. And we're going to jump into what is the distributive property today. So this is very algebraic thinking, so we're kind of putting on our algebra brains today. But before we get into the algebra part of it, let's look at it with just kind of some basic numbers first. That's going to be my starting point. So let's just think in numbers. And here's kind of my easiest way to introduce distributive property. I like to think of it as problems like this. Imagine we had to multiply 7 times 12. 7 times 12 you may have memorized, but you may not have, and you might have some shortcuts in your head. Here's one of my ways I like to think about this. We're going to think of this as an area problem. So 7 times 12 means we have a rectangle. Let's draw a rectangle that has the dimensions, the length and width of 7 times 12. And to find the area of that rectangle, remember area is length times width. So we're finding the area of our rectangle. But to do 7 times 12, I'm going to kind of do what I call a cheat. I'm going to break up the 12 and say, well, if I measured out 10, and then drew a little line, and I measured out 2 more, 10 and 2 make 12. So my shortcut is, I'll find the area of this little section, which is a 7 by 10. 7 by 10 is easy. That's 70 for me. And I'll find the area of this little region, which is, this is 7, so is this. It's a 7 by 2. So in this little region, I have 7 times 2, and 7 times 2 is 14. So the area of my entire rectangle is 70 and 14, and we know 70 plus 14 is 84. So we found our answer, 84. But how we found it is we used kind of a trick where we said, oh, let's make it easier. 7 times 12 is kind of hard, but 7 times 10 and 7 times 2, that's a little bit easier. That's distributive property. Now let me show you it using kind of distributive language. So instead of drawing the rectangle, let's look at it with distributive. Here's how I would have written this with distributive property. I would have said, okay, I want to do 7 times 12. Well, that's kind of hard, so I'm going to break that up and say, well, I'm going to do 7, but instead of 12, I'm going to break it up into 10 plus 2. Because 10 plus 2 is really 12. Okay, well that means I have to figure out what is the 7 times the 10. And then I have to figure out what's the 7 times the 2. And then I add my answer together. Distributive property. 7 times 10 is 70. 7 times 2 is 14. Add that up, you get a grand total of 84. And that's our answer. But that's how I show my work with what we call distributive property. And you're going to see a lot of teachers and people do this. They like to draw arrows. They like to say, okay, we did 7 times the 10, and we did 7 times the 2. So 7 times 10 and 7 times 2, distributive property. The way we're going to be practicing this in class, though, is we're going to bring in that algebraic thinking. So there's going to be some variables, maybe an x, maybe a y. So I'm not really loving that I use x for times, because that's a little bit confusing when I'm going to be using x as a variable here soon. So maybe I should convert all of these to the dot instead of the x. It might have been a little smarter of me. So let's dive into this algebraically. So we kind of see it with numbers, how it works here. Now let's look at it with algebra. So I'm going to write it in the corner here, algebra. What does our problem algebraically look like with distributive property? Well, here is an algebraic problem. 4 parentheses x plus 2. This is distributive property, and we have a variable. We have x. So I don't know what this number is. It could be 10. 10 plus 2 makes 12. It could be 100. It could be 93. I don't know. We don't know what x is. That's our variable. So this thing right here is unknown. But it doesn't mean we can't do our distributive property. Now, let's picture it as a rectangle. So what I'm going to do is I'm going to draw a little thought bubble over here about what's going on in our head. And my thought bubble is going to be a picture of what does this look like. 4 parentheses x plus 2. What that means is I have a rectangle, and I'm multiplying 4 times x plus 2. This is what it looks like. So imagine splitting it into two regions. This region is 4 times x, and then this region, since it measures 4, is 4 times 2. I know 4 times 2 is 8. That part I got. 4 times x, since I don't know what x is, I really don't know what it is, but I know it's 4x. So look at what our answer is. It's 4x and 8. We would add them together. So our solution is 4x plus 8. And I showed a lot of good work in my little thought bubble here. This is what I would call my visual. So it's a real pictorial way of seeing it, but I didn't have to do it that way. I could have used those distributive arrows. I could have said, okay, I'm going to do 4 times the x. I'm going to do 4 times the 2. That means I'm going to do 4 times x and 4 times 2, and I'm going to add them together. 4 times x is 4x, and 4 times 2 is 8. Same simplified solution here, different process. So there's kind of two ways to do this. You can do it with the arrows, or you can do it with the picture. I bet if you can do show me both, it's kind of your advanced level 4 thinking at this point in time. So a couple of things to note. We are not solving right now. I didn't solve for x. I don't even know what x is. There's no equal sign in this problem to do any solving. All we're doing is simplifying. So this is just a simplify technique. So when I say let's use distributive property, I'm really just simplifying or changing how the problem looks. This and this mean the same exact thing. So last little step here, I'm going to write 4 parentheses x plus 2 is actually equal to 4x plus 8. They are the same thing, just two different ways of writing it. And why are we practicing this skill? Because eventually we are going to solve for x, and this distributive property step is going to help us do the solving. So we want to know how to distribute if we're going to solve for x later down the road with it. So right now the focus is just on simplifying. So now that we've looked at it with numbers and algebra, let's just practice some examples and see if we can get the hang of this a little bit. So I'm going to write example 1 now. Let's start trying some problems. Now my directions are going to be simplify, because we're not solving yet. So simplify. And here is my problem. I want to simplify 3 parentheses x minus 5. 3 parentheses x minus 5. Now, because these are my notes, I'm going to try this 2 different ways to go for my level 4. I'm going to do my basic algebra, which is draw the arrows and multiply the 3 inside. We're going to do 3 times the x. We're going to do 3 times the 5. And then what goes in the middle this time? This one's different. It's a subtraction problem. So we're going to bring that subtraction sign down, put it in the middle. 3 times x is 3x. 3 times 5 is 15. And we've got a subtraction sign in the middle. There it is. There's my simplification. 3x minus 15. And I'm done, and I've simplified, and I could move on to the next problem and be totally happy. But here's my level 4. If I'm like, man, I really want to go for that advanced thinking and get a level 4. That means I'm going to make a visual. And a visual would be to show the area model, to show the rectangle. If it's 3 parentheses x minus 5, well, here's my rectangle. And what that means is, on my rectangle, my dimensions are 3 and x minus 5. So to break up the rectangle, I'm going to split it down the middle. This side will be 3 times x, and this side will be 3 times negative 5, a minus 5, a subtracted 5. Well, that makes a minus 15. Different signs. 3 times negative 5 is different signs. They don't match. That's bad. That's a negative 15. And 3 times x is 3x. Same exact answer as this, 3x minus 15, just another way of showing it. There's my level 4 right now. I've got the visual and the algebra. Okay, so why don't you give this a try? Let's do a you-try problem and see if you've got the hang of this. If you do, that's awesome. So here is your you-try. And this is something for you to try on your own to see if you've got a handle on this problem. So your problem is 6 parentheses m plus 4. Right now, hit the pause button on your device and go ahead and simplify this on your own with distributive property. And then when you're ready, we'll check your answer. All right, you ready to check? Depends on how you did it. Did you go for the visual model, or did you just use the arrows, or did you do both? I'm kind of curious. If you did the arrows, you did this. You said 6 times m and 6 times 4. 6 times m and 6 times 4 with a plus sign in the middle. We're adding. That makes 6m plus 6 times 4 is 24. There is my simplification. 6m plus 24. If you drew the visual, then you drew some sort of a rectangle with 6 and m plus 4 as the dimensions. And when you break that up, 6 times m is 6m, and 6 times 4 is 24. Same exact answer, just another way of showing it. So how did you do? Do you have the same thing as me? If not, look for where you might have made a mistake. Now, I'm going to show you a couple more examples still because there are other types of this. So for example 2, I want to show you how we can kind of vary this up a little bit. Let's put a negative sign out on the outside. So we're going to write simplify. And this time I'm going to tell you that it's a negative 2 parentheses. And in the inside of this thing, I have 4y plus 1. How about this problem? We're going to simplify it still with distributive property. To be honest, I see the parentheses and I'm like, oh, I got to distribute. And I'm going to go for using the arrows this time around. I'm going to take this negative 2 and multiply it in by the 4y and by the 1. And I'm going to be very careful about how I write this out. So my job is going to be negative 2 times the 4y and negative 2 times the 1. And the sign that goes in the middle, we're adding. It's a plus, so we got plus. Now, negative 2 times 4y, what's a negative 2 times 4? Well, 2 times 4 is 8. Negative and a positive don't match, that's bad, so it's a negative 8. So all I have to do is say it's a negative 8y. I'll put the y with it. And negative 2 times 1, well, 2 times 1 is just 2. But again, these don't match in signs, so that's bad, that's a negative 2. And then we're adding it together, so we get this. So if you want, you could leave your answer like this, negative 8y plus negative 2, and you could say that's your answer. But there are a lot of people that are like, the plus negative 2 is too many signs. I just want to write it like this, negative 8y, and then a minus 2. And that's mathematically the exact same thing. It's kind of like undoing heap change. So I'm going to say either one of these is totally fine as a solution, whichever one you prefer. Negative 8y minus 2. Or negative 8y plus a negative 2. Okay, so let's look at another one here. We'll do an example 3. Move that off to the side. Why don't we throw a fraction in there and make this real exciting? Okay, example 3. We're going to simplify. So simplify. And this time, like I said, we're going to throw a fraction in. So we're going to do 1/2 parentheses. And in this parentheses, we're going to have 4 plus 6x. 4 plus 6x. Again, I like to use the arrows, so that's my strategy. I'm just going to draw. I'm going to say, okay, I have to do 1/2 times 4, and I have to do 1/2 times 6x. So that means I have to do 1/2 times 4, 1/2 times 6x, and then there's a plus sign in the middle, so we are adding. So 1/2 times 4. With fractions, we multiply the top number only. 1 times 4 is 4, but now it's 4 halves. 1 times 6x. 1 times 6 is just 6, so that's just 6x, but it's in halves, and we are adding it together. What do fractions mean in algebra? They actually mean to divide. So 4 halves means 4 divided by 2. 4 divided by 2 is just 2. 6x divided by 2, well, what's 6 divided by 2? Well, 6 divided in half is 3, so we get 3x. And we are adding these together. There it is. That's our solution. 2 plus 3x. And we are simplified. So you can see, like, I could maybe throw some decimals in there. I could change it to some negatives. You can really modify these problems. But the process that I'm showing is pretty much the same every time. I draw my arrows. I make sure if it's an adding or subtracting problem to put the right sign down the middle. And then I just kind of slowly go through my multiplication math and make sure I don't make any like small mathematical errors. And that is distributive property. Now, if you opened up a math textbook and you looked up the actual property, distributive property, they're going to show it very, what I call generically. Let me show you what it'll look like. So if you open up a math book, you open up your high school textbook or something like that, this is how they're going to show distributive property. They're going to show A, parentheses, B plus C. And the ABCs could be absolutely anything. They could all be numbers, like 7 and 10 plus 2. Or it could be like 3, x plus 4, 9, x plus 2. I mean, it could be really anything. But the strategy is you do A times B, A times C, and you get your answer of A times B plus A times C. That's distributive property. Just multiply things in. Now, the only way we could change this is we could say, hey, it's A parentheses B minus C. Okay, well then my solution when I do my arrows is I'm going to do A times B, A times C, but I'm going to be subtracting A times B minus A times C. Again, the ABCs represent anything. They could be numbers, they could be variables, they could be numbers and variables, they can be lots of different things. But that's what it's going to look like if you open up any kind of like high school textbook. They'll show it real generically like that. So hopefully you feel like after watching this video you can have an idea of what distributive property is. Maybe you've used it before in the past and this was just review. We're definitely going to apply this in class and start solving for these variables using that distributive property. So thanks for watching, guys, and of course see you in the next video.